What's up? I'm Troubleshoot. Welcome back to another video. In this quick one, I've got some amazing news for you, and that's to do with Microsoft and Nvidia coming together for Stable Diffusion improvements. They're offering 2 times speed increases just by updating your Nvidia graphics driver. Here they talk about on May 24th, we'll release the latest optimizations in release 5.32.03 that combine with Olive optimized models to deliver big boosts in AI performance using an Olive optimized version of the Stable Diffusion text-to-image generator. With the popular automatic 1111 distribution, performance is improved over 2x with the new driver. So 2 times the performance for generating images at 768 is great. Improvements of any kind are appreciated, and when it's 2 times, that's even better. Heading across to the link that they mentioned here, you'll find both of these down below. They talk about getting the best performance with DirectML, which is the new backend for Stable Diffusion that you'll need to use instead of PyTorch. That does mean that huge changes need to be brought in for automatic 1111 Stable Diffusion, WebUI, and other programs like that, as they now need to use DirectML instead of Torch in order to use these new models, or at least as far as I understand. We'll get to testing that later on. Heading across to the Nvidia driver download website, you'll see 5.32.03. They're talking about 2 times inference performance on popular AI models and applications such as Stable Diffusion, which is crazy. All you need to do is download this latest driver, and assuming you have an RTX graphics card, it should now be able to tap into all of your RTX AI cores and things like that, which it previously wasn't able to do with such performance as they're offering now. Now, assuming you've downloaded the latest graphics driver, we can get started. How? Well, first of all, they talk about Olive optimized models, and obviously most models aren't Olive optimized. It's a brand new thing. Heading across to GitHub, Microsoft Olive, you'll find Stable Diffusion optimization with DirectML. Stable Diffusion comprises multiple PyTorch models tied together into a pipeline. This Olive sample will convert each PyTorch model to ONNX and then run the converted ONNX models through a transformer. The transformer optimization pass performs several time-consuming graph transformations that make the models more efficient for inference at runtime. Output models are only guaranteed to be compatible with ONNX DirectML 1.15 or newer. Scrolling down further, we see how to install this new toolset using these commands here, and finally, how to convert models to ONNX and latency optimization. We can simply run this command here, and it should convert models, test inference down here to generate images, lower models, and finally they go into more information about the Stable Diffusion pipeline. Alright, before we continue further, just a quick note about automatic 1111 Stable Diffusion WebUI. There are a few discussions talking about this new update, but they sort of end up with, you'll have to convert models to get the speed improvement, but WebUI doesn't use ONNX, so it doesn't apply. The DirectML fork should make good use of it. We'll get back here in just a moment. Automatic 1111's development is a little bit quiet, or at least hidden away in a developer branch. So looking at the Vladmantic fork of the WebUI, we see people talking about it once more here. Though scrolling down further, we'll see an official response, or at least as close to an official response as we'll get. So Vladmantic doesn't have much faith in this. Olive optimized models means compiling models from Torch to ONNX and then using the new ONNX backend with built-in tensor core support. This does mean that the entire Stable Diffusion ecosystem should stop using Torch, CUDA, ROCm, etc. and switch to ONNX, which is highly unlikely. And if going down that path, I'd rather support TensorRT directly instead of ONNX, unless someone says that ONNX is the next best thing and will completely surpass Torch in the near future. Microsoft uses ONNX internally in Azure for ML as a service, so this makes Nvidia a much more interesting choice for Microsoft, and I get why Nvidia would do it. Why wouldn't they? But scrolling down a bit further, we have a response from Ishkuki Tiger, or however you'd say it. They looked at this yesterday. It generated 512 images at 2.03 iterations per second instead of 1.5. It'll be faster on the latest Nvidia driver, so they didn't test this on the latest hardware. But it is for ONNX runtime, so it is difficult to apply for now. Having a look at their profile, repositories, you can see that they have a DirectML fork of a Stable Diffusion automatic 1111. We'll get to testing this later on to see if we can use the improvements in this fork. It is, however, outdated, compared to the latest Automatic 11 distribution. Anyways, we're getting ahead of ourselves. Let's start at the beginning of converting models to Olive. So in order to set this up, all we need to do is install a stable release that they've already validated. For example, running these commands here and these two. You'll find this in the description as well as the plethora of other links. I'll make a new folder on my desktop called Olive, for example. Click at the very top in an open spot and type in cmd. Otherwise, if you know that your Python needs admin to install packages, you can open up a new terminal as administrator, copy the current path that we're in by clicking in an empty spot, copy, cd, and paste. Now that we're in the correct folder, we can run the install commands, so pip install Olive AI, and of course I'm getting errors here. Let's just make a new conda environment, just to make sure things are organized and there won't be package conflicts. Then I'll activate it, so conda activate Olive. Now we can go ahead and run the next few commands. So we'll install Olive, which could take a bit of time, and when it's done, we'll also run the next command to clone the Olive files. You'll now see a new Olive folder inside of it, followed by examples, then DirectML and Stable Diffusion. We have these files here. This is what we'll be using in the next command. It'll change us into the correct directory, then install requirements. Awesome. Now we can run Python Stable Diffusion PyOptimize, which will enumerate the config model name JSON files and optimize each with Olive, then gather the optimized models into a directory structure suitable for testing. So if I run it here, it's downloading the PyTorch pipeline, then it's optimizing the text encoder, optimizing the encoder, as well as other bits of the Stable Diffusion pipeline. This could take some time. And there we go. If we have a look in the models folder, we'll find optimized runway ML, Stable Diffusion 1.5, and unoptimized as well. Now if we test inference speed, for example, we can run the next command, or clear run the next command, which will generate two images. We can go ahead and type in maybe, I'll leave it as is, that's fine, generate, and now we should see a response here in just a moment. So we have one image and the second image here. Obviously it's Stable Diffusion, nothing too crazy, but at 19.7 iterations a second, it should be quite a bit faster than using Stable Diffusion WebUI. Let's take this prompt and close this, and we'll test out Runway ML Stable Diffusion 1.5 in Stable Diffusion Automatic 11.11 WebUI. So is it really faster? Well, we have the output images here, and they're 512 by 512 pixels. If we fire up Stable Diffusion WebUI, punch in the same prompt, and generate, you'll see that looking at the terminal, we're getting around 10 iterations a second. If we raise the batch count to maybe 5, just so we can watch it, we should see that we're sticking around 8 to 10 iterations a second, meaning that the newer method, Olive ML, is a lot faster, as that's sitting at almost 20. It is twice as fast. But if we instead edit WebUI user.bat for Auto 11, I've added these two commands here. These should make it process images quite a lot faster. Run the same image generation, and this time you'll see that it's working at around 13 iterations a second, so it's quite a bit faster, but it's still not really 20. For every 3 images generated here, we can generate 4 using Olive, so it is still faster. But it comes with the drawbacks of not being able to use a WebUI like this, at least yet, as Olive is very, very new, being released literally today, and with creators of popular WebUI models saying it probably won't be supported soon. Alright, let's try use these new optimized models in Stable Diffusion WebUI. I doubt this will have any positive effect. If we copy the Stable Diffusion folder here and place it alongside our current models, we should see that it doesn't show up at all, or doesn't work properly for that matter. Let's try it. Refreshing my models list, I don't see it at all. Obviously, it can't be loaded. Alright, let's try the Auto 11 fork. Even this, I'm not too sure if it'll work. So I'll simply download this one here. So I'll change back to this directory a few times as such, and we'll go ahead and git clone the fork for WebUI, open it up, and we should hopefully be able to place the model in the models folder here. So I'll copy and paste it in, and we'll go ahead and run it. This should download and install all the packages necessary. Alright, there we go, it finally launched up. I had a few issues. First of all, I had to manually install PyTorch with GPU support using the official install command from the PyTorch website. Then it still didn't work. I had to run pip install torch directml, and after that, the WebUI is finally launching up. While I was speaking about ishQQ Tiger's model supporting directml, it doesn't seem to detect the model, even though I've placed it into the models folder, then Stable Diffusion, right over here, next to the original Stable Diffusion model here. You can see all of these ONNX files, but unfortunately they don't seem to be supported. I'm not entirely too sure how to get this to work, but anyways, it's not working here at least. That was a bit of wasted time setting this up. What else can we try? Well, in very recent developments, this Stable Diffusion client here, Stable Diffusion XUI, apparently supports ONNX models, which is what we're trying to run. So we'll download the latest release, and we'll see if we have more luck with this. Now for this, we will need 7-zip installed to use it. Let's see if we have more luck. XUI, we'll run XUI exe. Welcome. Diffusers is an API that works on CUDA. This UI has several implementations of Stable Diffusion, which are suitable for both AMD and Nvidia. Diffusers is an API that works with CUDA, ONNX, and CPU. It's recommended minimum of 12 gigabytes VRAM. This algorithm works with models in Diffuser. To transfer your checkpoint safetenses file to Diffuser, use the import button. So I will use ONNX here, and I'll install the packages required for it, which will run the commands necessary. We'll just wait for this to finish, and there we go. Now that it's done installing the runtimes, it should launch up again, I assume. Oh, never mind, it opened on a different screen. Here we go. Using the ONNX virtual environment, we'll leave everything as is, but for model, import, which pulls up the model importer pop-up here, I'll select safetenses, as that's what it is, 1.5, ONNX, and we'll drag and drop the 1.5 safetenses here. When we've done this, the path shows up, convert, and it says conversion or convertation, in this case, should take about 5 minutes, although it shouldn't take that long. Okay, so even though it says that it's done, it's still using a heck of a lot of disk speed, or at least it was, and now there's a much bigger ONNX file in here, so I assume the process just didn't finish when it said it actually finished. And now though, as you can see here, more files are popping up, more disk usage is being used, so we really just need to hang around and wait until it's fully done, even though it says it's done. There we go. Okay, another pop-up in the bottom right of my screen. Everything is now done converting. So we can close the importer, look at this once more, and select the new model here. Alright, so I'm entering the same command and clicking make. Now we should see an image returned here in just a few seconds. Wait, it's using my integrated GPU instead of dedicated. That's not good. I'll select my correct graphics card and try again. Although I can't cancel it, let's just relaunch it. And let's run the same prompt here with the correct graphics card and make. Now it should go ahead and generate the image as such. But how fast was it? Well, clicking the command line button here, scrolling down in the log, we can see 5.6 iterations a second. Definitely a lot slower than both Stable Diffusion WebUI and the new ONNX tester or converter, so I'm not entirely sure what's going on here, but at least it does work with these models. I assume this program will improve its speed and things like that as time goes on. It is pretty featureful for something that's not a WebUI and really easy to use, but it doesn't seem very fast. Maybe I'm missing something though. And of course, maybe I'm missing something with the WebUIs trying to use new ONNX models, but anyways, for now at least, there is a huge speed improvement to be had. It's just you can't really use it, or at least yet. You can sort of use it with Microsoft's Stable Diffusion Python script, but other than that, not really at all. Anyways, exciting times are to come. If you'd like to try them out, you'll find links to all of the different projects that I showed off in this video in the description down below. If you find out more information as this thing goes on, please do let me know in the comments down below, and I'll hopefully get to updating this video. And of course, it'd be great to see this kind of functionality and speed improvement in Auto 11's WebUI, as that's the most popular go-to place for generating images. Thank you all for watching. My name's been Troubleshoot, and I'll see you all next time. Ciao.